Hello, welcome. You want to install a virtualization server with Proxmox, or you are not sure how to do it, or you want to validate your IDs, then you are at the right place already. My name is Joel, and today I will show you how to install and configure a Proxmox server, and how to set up the ZFS file system, as well as discussing about the hardware I've chosen for my own environment. So stay online. In a few seconds we are starting. Almost 2 years ago, my old NAS began to show some issues. From time to time it didn't work anymore, and the web frontend was no more accessible. And on top of that, the disks were pretty full, and I needed more capacity. It was time to start thinking about a new system. But what? A NAS? A new NAS? I was not much impressed by my old NAS. Too slow, configuration not very trivial, no or almost no extension. I started to search for a new solution. I just wanted to exclude NAS solution, but it was definitely no more my main interest. I looked for a new NAS solution and found out that you can have some systems that are affordable from a price point of view, but without any real performance or any possible extension, or you can have some that are very almost anything that you want to have, any extension, a big CPU, many memory, but with the price of a high-end game computer. So I came back and started to experiment on an old notebook with a few solutions. I started with FreeNAS. Not really that what I wanted. I started with VMware. Okay, it was pretty good. But if you want to do some of the things that I needed, I would have to have a license for that, and I don't want to pay that much. So I came back to Proxmox. It's almost the same as VMware, a little bit and not so functionality, but still a full virtualization environment that is pretty good working. Proxmox, you can buy a support license for Proxmox, but you don't need it. The product is freeware, and it's not mandatory to have a support license. If you don't take that, you will just be reminded about it when opening the web frontend. But I think, okay, one click and it's away. It's not very much. So I will show you how to install and configure this solution, but it's time to show you which hardware I choose for my solution. I decided to set it as follow after a few researches. The case, I took a Silverstone SSD DS380. It's a case that have 8 hot swap disk possibility plus 4 disk internal. The main board was an Asus ROG Strix Z490i. The CPU is an Intel Core i5 10400 with 6 core. The RAM, I took a non-ITZC 64 GB from HyperX Furry Black. I have a Samsung 970 Evo Plus M2 disk for the operating system, and 2 internal SSD for WAP and the logs on the ZFS system. The SATA controller is MZU SATA PCIe with 8 SATA ports, and on the main board I have 4 SATA controllers. The disks are 4 Western Digital 40 EFRX. Those are my old disks that were in my NAS. I bought 4 disks Western Digital 40 EFAX, that's the new one, but practically the same. Those are NAS disks. And the 2 SSD with 500 GB for VM and for the logs on the ZFS. So I choose the case because of its size and disk capacity. This case is very small despite the amount of disk that can be hosted. We have altogether 8 3.5-inch hard disk drive hot swap tray and internal 4 2.5-inch hard disk drive capacity altogether. On the main board I have 4 SATA adapter, and the extra card, PCI card, come with 8 SATA port, so I can altogether up to 12 disks. This should be sufficient. On top of that I can have 2 M2 disks on the main board, so this is why I choose that. The CPU has 6 core, also 12 CPU with hyper-threading, and it's fully sufficient. After almost 2 years of usage, I never saw the CPU rising above 30–40%, and the average is at between 5 and 15%. The RAM you need, at least I think, if you want. At the moment I am running 6 different servers all the time, and the RAM usage is at 60% of the 64 GB. So if you can do it, install as much RAM as possible. If you say, okay, I need only 1 or 2 servers, and from time to time I want to install an operating system to test it or to play with it, then 32 GB will be okay. The first try I've done, this was an old notebook, and I had 8 GB, and it was working. Okay, it was pretty slow because it was almost 10 years old notebook, but it worked. I had my Nextcloud installed on it, and it was pretty good. Now, I want to discuss the point of the decision of ECC RAM or not. I choose to use non-ECC RAM. Why? For my ZFS file system. So, okay, pretty important. I think the cost. It was ECC RAM would have cost 3 times that what I paid for the non-ECC. And I think it makes no difference when using a journaling file system, no matter which one, extended for ZFS, BTRFS, ZFS, or any kind, or JFS, or anything else. If you don't have any ECC RAM, you will not have 100% security. So it can happen that you have a RAM error, and the data will be stored with an error. The difference between ZFS and the other file system is that ZFS, if the data is corrupt, it will never allow to load it. On other file system, at least you could open it with a binary editor and try to reset the header or the data, but it will cost you more time to do that than to rewrite the data or recreate the data. So at the end, it makes no difference. If you buy non-ECC RAM, if you have an error on the RAM itself, it will appear within a few days. You will see, you will have error, the server will crash down. So if you don't have any issue, then it will run without any trouble. The only thing you have to do is have APU, so auxiliary power unit with battery that allow you to run even if the power is down in the vicinity of your house. You are able to shut down the server correctly. All the data will be stored to the ZFS disk and everything is okay. So until now, I never saw an error with the RAM, and it's running since, although in March, it will be 2 years that I have it. At the time, I have 6.3 terabyte of data on it. I just had 2 weeks ago a disk that crashed down or was no more reachable, so I have to change it. It was a matter of 10 minutes after I received the new disk, and it took around about 6 hours to rebuild the Red Z, but the server was still working. There was no downtime. So now, if we want to go to the installation, we will need a terminal session. If you are using Linux or Mac OS, just open your terminal or bash. On Windows, you can use PuTTY or Mobile XTerm. Both are freeware. You can download them, or at least limited freeware for Mobile XTerm. But you can use it without any license. It's restricted, I think, to 8 different servers. You will need a USB stick, 4 or 8 gigabyte, and of course your new computer where you want to install Proxmox. The USB stick is in the server. We have now to start it. And just click on Install Proxmox Virtual Environment. And here we are. You have to agree to the license. Now choose the disk where the operating system should be installed. For me, it's dev SDA. And next. So fill in your country and time zone. I'm in Germany, so I choose that. You have to take the country and the time zone as well as the keyboard that you need. Type a password in. This will be needed to log in your web frontend or to log into the CLI, and just add an email address where the server can send information to you. Oh, with so better. Next, now fill in the hostname as FUDN, as a full qualified domain name. That means the hostname and your domain. IP address. You should choose a static IP address, the gateway, and the DNS server. I put a DNS server that is configured in my network, in my intranet. If you don't have one, just add your gateway as DNS server. It will relay the query to the outside if necessary. Check the value and click on Next. So this is the summary. Automatically reboot after successful installation and install. So the server is rebooting. So our server is now there. We will now change to the console. So and we change now to with secure shell, root, add PVE. So if your host has no DNS record, you will need your IP address that you have taken during the setup of the server. Just IPS, the password you have typed in, and we are in our server. So installation was successful. We could do the same on so we could just put our server name or the IP address in the browser with the port 8006, and you should receive something like that. Website, type root, and the password, your password, login. Okay. Here is our server. We have automatically in the operating system disk, we had storage, local and local LVM configured. The first one is needed for ISO image or city template, and the second one will be needed once we have created a container volume, a container or a virtual machine. The disk required for the server will be put there. So now what we can do is, for example, going to local, container template. You can go to template and choose, for example, we could take the last Ubuntu version and click on download. So you can close the window. You have the job as task further down. So now it's finished. And we have our Ubuntu ready for installation. That means if I'm going to the PVE server and just tell create container, I just have to put a host name. You could choose a resource pool. Just give a password for the server. You could add a secure shell public key if you have one. The storage is local. Template, the one we have uploaded, Ubuntu. Then on next. Disk, 8 gig. It's okay. CPU, 1 core is okay. Memory, we could say 1 gigabyte. Network. When you are setting up a server, I would definitely choose static IP address. In this case, we could go with we choose a DHCP for this server, but you should choose a static IP address if you want to use a server in a later state. DNS, you can let it as is, use host setting, or you can choose different setting if you need them. So DNS domain and DNS server. Next. Then the review, configuring and finish. Extracting, task OK. And we have our server here. You can still change anything what you want on the resource, on the network, DNS, some option. You have a point for backup. We will see that a little bit later. Replication, snapshot, and all the possibilities that we have. If I click on Start, I can see here on the summary that the memory usage and CPU is rising. The server is starting. And with the time, the CPU usage will be filled up. So if I go to the console, IP address that has been given is 131. So yes, and I am logged into my server. When you don't have any public key defined during the installation, you will be prompted for the password. So we have our Ubuntu. As requested, 22. Server is working. So we can now exit. So there is still one point that we need, and this is updating our server. As the Proxmox standard version is only for enterprise, that means that you need to have a license if you want to be able to access the enterprise version. We have to change the configuration for the repositories within our server. So, as I told you, our system is ready, but there is still some step missing. In order to always have a system that is up to the latest version without bug or any error, we have to set up the repository to receive periodic update from Proxmox. From scratch, the server is configured for the enterprise version. As we don't have any subscription with Proxmox, we have to change the repository from enterprise to the open source version. So we go to our terminal, and what we have to do is just add some source in our repository. So we just add some So this is the repository itself. It has been added, and we have still, you have to make sure that you give two bigger sign in order to add the command and there is the new repository at the end of the source list. If you only put one, you will overwrite the source list file. The command written here are in my homepage. You will find the link under the video in the comment. And we still have one step to do, is to deactivate the enterprise repository. And this time, make sure we have only one bigger sign, as we want to overwrite the file. So we check our changes. So we have it here. And the second one is the enterprise list. And you see at the beginning of the file, we have a sign to comment the line. Now we can just give apt update. Oh, let's see. So we have some update to run. So the first possibility is to install them from the command line here. That will be apt upgrade. Or what we could do too is to go to the browser on PVE on our server name and check for the update. And as you can see, we have some packages. In this case, you just have to go to upgrade. A terminal will be open and you will see the upgrade running on the command line of your server. So now let me go back and show you this from the command line. -yes. So you will not be prompted for the next steps. So finished. As we have a new kernel, we should reboot the server. In the next time. So browser, let me show you. We are here. There is still one point that we can configure on our web server, define web server. If I go to option, I can tell the server that it should boot automatically when the Proxmox server is rebooted. And if you have more than one server with dependency between the server, you can just change the order and set it start shutdown order. This will be 1, 2, 3, 4, 5, the normal order that you want to have. A startup delay and a shutdown timeout. That means if the server is being shut down, then if the dependent server is being shut down, this one will shut down too. So we don't need anything as we only have one server defined. Now, what we can do is shut down the server. When our server is again there, just have to refresh the browser. Our PVE server is again up and running and our web server was started automatically. So server is finished. We have the update configured. What we need now is to configure our disk as a storage for our environment. So we want now to configure our disk. It could run as is, but we still have some disk that we want to use on our server. To do that, we have to configure them. We can go directly to the web frontend or from the command line where we have more configuration possibilities. If I go to the web frontend, I choose my server, go to disk, and you can see here we have two disks with around about 11 gigabyte and 4 disks with 21, also 20 gigabyte. So we want to use those disks. Of course, for you it will be 4, 8, 10 or 16 or more terabyte. So it's just a test system, so I have only a few gigabyte disks there. But for the test, it's okay. So we could go here and configure our storage manually, also from the web frontend. But I told you we have more possibility on the command line, and I will do it on this way. Root at PVE. So I added my public key to the server, so I was not prompted for a password. If you don't have any key, you will be prompted for your password. So we are under Linux, so lsblk, you can list your disk. You see them there. I have the SDA, is my operating system disk with 128 gig. It has been configured. We have LVM configured with root swap, and we have two logical volume, one for the data, meta and T data. Those both are the two disks that we saw on our PVE web frontend. One is called the local and one is called the local VM. This is where we are storing the ISO file, and the second one is for the disk of our virtual machine or container. So we could see this disk here, for example. This is the disk of our web server that we set up a little bit before. So now I choose ZFS as file system. Why? So this one has almost no restriction for capacity. The storage can be expanded up to 2 to the potent of 128 byte per pool, and I think it's more than we will ever need, or at least for our purpose. So on ZFS has more possibility for snapshot. Is you can add as many disks as you want. I will always recommend to set up, of course, some kind of thread. On the ZFS, it's called RAID Z for RAID 5, RAID Z2 for RAID 6, or RAID Z3. Those one have the number of disk that is taken for the parity. That means if you have 3 disks, you will only be able to set up a RAID Z server. That means you will have 2 disks for data and 1 disk for parity, even if those are spread over the 3 disks. But that means that if you have 3 disks with 4 terabyte, you will have 8 terabyte space on your file system. RAID Z2, it's recommended from, can say 5, 6 or 7 disks. And RAID Z3, I would set up from 10 disks or 15 disks. We go back to our disk here, and what we need first is to know the physical sector of our disk. We will need them for the setup later on. So that means, okay, if you want to sudo lsblk, if you want to root, if you are root, you can just issue lsblk. Oh, sorry, it's not configured there. So, and we see our disk have a physical sector of 512 bytes. That means we have a small table, you can find it in internet, but I can't tell you here. For physical sector of 512, we will have an hash shift of 9. For 4096, that is practically disk with 4 or 6 terabyte. You will have 12, an hash shift of 12. For any disk at 8192 byte or higher, you will have an hash shift of 13. So in our case here, we have SSD and we have 512 byte physical sector. That means we will need an hash shift of 9. Now, if I want to create my pool, the command is zpool create -f data. This should be the name of my pool. So now -o for option, hash shift is equal to 9. For you, depending on the physical sector, you will have to change the hash shift to whatever you received during the test. Now, second option is auto expand, sorry. Is equal on. That means if you change a disk for any reason, you want to have bigger disk or there is a problem with the disk and you want to have more capacity on your disk, so you will maybe add a disk with 16 terabyte instead of 4 or 10 terabyte. Once any disk within a mirror, once those disks are all on the same level, that means you have 4 disks, you change every disk to 10 or 16 terabyte, then the pool will automatically expand to the new size that you have. So now I want to set RAID Z. This is equivalent to a RAID 5, that means 2 disks for data, 1 disk for parity. And now I will add my disk. We have them here. It's SDD up to SDG. And return. Oh, the SDD, SDE, oh, SDF. So our pool is created. We have data. We have our around about 80 gigabyte, and all 3, no fragmentation, and the disk is online. If I change to my web frontend, we can now go to PVE. So just renew. So, and we have here our disk configured with ZFS. If I go now to ZFS, there, you can see our data. So what we want to do is we don't want to set any disk, to allocate any disk there, but we want to create virtual device. So we go back to our terminal, and what we now want to do is create with ZFS, create -o. So extended attribute, I would set it to SA. Those are recommended if the virtual device that you are setting should be set up as share for Windows or for Samba. That means it's then possible to set extended attribute on file stored on this system. I would set it up even on our VM. That means the file system is then open for some share if you need them in the future. But for the VM, we don't need it really at the time. So second option is compression. I would set it to LZ4. Standard is LZGB for ZFS, but I would take LZ4. It's a little bit faster. Don't need so much CPU or RAM. So -o a time equal off. That means in setting this off, your file system will not be changed if you are only pointing at them, accessing them in any kind of not even editing, but just showing the file. That would mean that that would request CPU and RAM again in order to change this access time, and we don't need them. I don't want to know if my data has been displayed with the LS or in a browser in a Windows browser. Somebody has looked at it without any change or not even opening the file, but it's taking time and resource to change the access time. So set it to off. Is better. -o record size. I would set it to 16K. That means if you have a file with 16 kilobyte, it will take only one block. If you have a file with 32 kilobyte, it will take 2 blocks on the disk. But if you have a file with 8 kilobyte, it will take 1 block, even if you only have 8 kilobyte. So you have to choose for each kind of file system what you want to use there. If you have only file with X terabyte or X gigabyte, then you can choose the record size a little bit higher than 16K, up to 1 megabyte or whatever you want. If you only have file with 4 kilobyte in a virtual device, then choose 4 kilobyte or 8 kilobyte at least. But I think 16 kilobyte is a good middle. So what I want to set to is the mount point. That means where should this virtual device be mounted? I want it to have on data. Oh, sorry. And its name is data VM. Return. And you can see I have my pool itself, data, and my virtual device that we have set up. Now I can go back here, click on data center, then on storage, then on add. You want to add a ZFS ID. We want to name it data. ZFS pool is data VM. Then on the second, we can choose if we want to have disk image or container. We only did disk image here, but you can set up container too there. So I would let it with both. Node. We have only our PVE, only one server enabled. We could click sync provisioning too, and block size 8K. We have set up 16K, then we can let 16K. Add. And we have our data here. That means if I go now to my web server, for example, and I can tell resource, add mount point. My storage is data. 8 gig. Path. For example, data. This should be backed up and create. So now, if I change to my terminal, and go to my server, you can see I have my new volume mounted on data. So we still have 2 disks on our server. As you see, we still have our 2 disks there. So ZFS has the possibility to separate the log of the file system and to put them on faster disk. That means you could have your 4 terabyte hard disk drive, and you can add 2 or more SSD and put your logs of the file system on SSD. With that, you have the possibility to accelerate the change on the disk. That means everything will be placed on the log and then later on change on the disk. For that, you have to define it. So the command for that is ZFS, of course. We want to add some disk. We want to add them to the pool data, and we want to have them on the log. As we have 2 disks, we can set up a mirror And we can here take SDB and SDC as mirror for our purpose. Oh, sorry. Sorry, we want to change the pool. Also the pool. Add data log mirror on our to disk. So now, if I go back to my pool, have this, and if I look at the status, we could see where our pool data, it's online, and we have an RAID Z1 with 4 disks, and our logs are stored on the 2 disks. Okay, here any disk are on SSD, so it make no sense to set it up. But when you have normal hard drive that are by slower than SSD, you should set up them. So I recommend around about 10 gig or 100 gig, depending on how many data you are utilizing in one time at a time. But more than 100 gigabyte make no sense. So I would set it up if you buy an SSD with 500 gig or 2 SSD at least. I would recommend to set up a mirror for that. You can partition those disks and use only one partition. Instead of dev SDB, you could use dev SDB1 as a partition, and it will set up only the 100 gigabyte or 10 gigabyte or whatever you want to set as your logs. So we're now finished. Our server is set up. Our storage is set up. Later on, we will have to set up other virtual device. Then we want to store, for example, film, music, personal video, or whatever you want. For your working data, I would use a cloud technology. We will see it in a later video, how to set that up. What can be done on the UFS is setting quota. That means you define a virtual machine. So if you see here, and I have for my virtual device all the capacity of our pool. So you can reduce that and set a quota with ZFS set quota equal. We can set it to, for example, 50 gig data VM. And now we have only 50 gigabyte capacity on our VM disk. So we are now so far. Our server is running, I hope without any trouble or issues. In the next video article, we will see how to backup this server. Because, okay, Proxmox is a very stable platform, but error can happen. Your disk can crash down, your server, you can have hardware trouble, and you need a backup we will see that in the next video. I hope this video was okay for you. It brings you advantage or more details about Proxmox. If you have questions, or please write them down in the comment. I will try to answer them. Subscribe to the channel, ring the bell, and up to the next video. Bye bye.